Let's go ahead and get started. So, I brought these up because we're gonna be doing some more work with radicals, and so I want to make sure that we're good with sort of more complicated expressions, just so that when we do these, it's not gonna be too big of a deal. So when you are trying to simplify these expressions, don't try and break these down early. Don't try and multiply this together and do all that stuff. Just you've got a 20 and you've got a 6. Just break 20 down. Got this 6 here. Leave this -2 alone. Ignore it for a while. Write it all out. 2, 2, 2, 3, 5, right? Well, here's a perfect square pair. These are all alone. They're little lonely boys. Leave them alone. So on the outside of the radicals, and then now we can take this -2 and multiply it in. This -2 is on the outside, so it's going to be multiplied to whatever's on the outside, right? -2 times 2. So this is your final answer, all broken down. We're going to do the same thing here. 5's already a prime number. We don't have to do anything there. 10. So if we look, we've got 2 single. 5's our perfect square pair, so the 5 comes on the outside, the 2 stays on the inside, and now we can bring out this -5, multiply it here, and our final answer, -25 radical 2. All right? Pretty simple. Don't try and squish stuff together because it's gonna be a pain in the butt because then you're gonna have to undo it anyway. All right. So with fractions like this, there's a lot of ways you can go. Like for example, if you see a perfect square somewhere, take care of that first. Let your life be easy, right? Or if you see factors that you can cancel, take care of those, right? You've got a 3 on top and a 3 on bottom, just they cancel out, right? 3 divided by 3 is 1, they go away. 16, you know that the square root of 16 is 4. Now, we've done this. There's nothing up here on top that has anything to do with what's here on bottom. You've got a radical on top. You've got a number on bottom. There's nothing more you can do with this. This is good where it is. Simplified. The radical 6 doesn't break down because there's no perfect square pairs in there. And then this is just a 2. So we're good. Same idea here. If you look, radical 16, don't try and do extra. This is already there. Leave it alone. Now, radical 12, let's break that down, right? 3 times 4, and then 4 is 2 times 2. So we've got a perfect square pair here with those 2's. What's left over is the 3, and now we can simplify what's outside. 2 over 4 simplifies to 1 over 2. Don't overthink these. These are not difficult. Simplifying fractions, it's basically you're just dealing with 2 separate lanes, the numbers and the radicals. All right? So What are we doing today? Why did we practice that? Because we're going to talk about two specific cases with special right triangles that have certain degree measures that are easy to work with. They're easy to work with because they always have a certain ratio that's a nice ratio between the sides. It's important to internalize this one. More than almost anything else that you do, this topic is going to carry you forward into pre-calculus. When you take pre-calculus, you're going to find that, especially during the trig unit, when you're learning about the unit circle and all of those things, these special right triangles are going to come up over and over and over and over and over again. And it is really, really helpful if you have those special right triangles in your brain beforehand, because I'll tell you, you could sit there and you could memorize everything. No one's going to stop you. But if you know your special right triangles, then you'll never have to memorize. So that's just a thing. So let's get into this. Our first special right triangle is called a 45, 45, 90 triangle. Why is it called a 45, 45, 90 triangle? Because the three angles are 45 degrees, and 90 degrees. Remember that if you've got two angles that are the same in a triangle, we call that an isosceles triangle. That means that the two sides that are opposite those angles are the same, right? So here's the thing. When we're working with a 45, 45, 90 triangle, we're going to have the ability to say to ourselves, well, I know one side I can just multiply or divide by the same thing each time to get the other side. So if I've got the leg, if I want to find the hypotenuse, all I do is multiply by radical 2. So if the side length here is 5, the hypotenuse is 5 radical 2. If the side length here is 22, then this is 22 radical 2. Whatever. All right? And vice versa. If I've got the hypotenuse and I want to figure out what the leg side is, all I have to do is divide by radical 2. All I have to do is divide by radical 2. So that's all we're doing here. If you're given the side, times radical 2 to find the hypotenuse. If you're given the hypotenuse, divide by radical 2 to get the other side. Now, I don't want this to feel like magic to you, so I'm actually really glad our book does provide, like, okay, well, so we know how to do this with the Pythagorean theorem. Let's just solve for the hypotenuse y, right? So you can see what's happening here is that the side times radical 2 equals the hypotenuse. All right, they give you a little proof here. This is why this is true. Okay? All right, cool. So let's move forward. Let's talk about some examples. Let's find the length of a side with our little ratio here. So here again, what am I given? I'm given the length of this leg, and what I want to find is the hypotenuse, right? So going from the leg to the hypotenuse times radical 2. So what's my answer? 9 radical 2. Wasn't that easy? Right? So let's have you try your own. All right. Let's have you try your own. And I want you to try this one. All righty. Let's go ahead and try this out. So once again, we're starting with a leg, and we need to find the hypotenuse. So let's multiply by radical 2. So we look at this, we've got 2 radical 2 times radical 2. Well, look at what we've got in the radicals. We've got a 2 and a 2, right? That's a perfect square pair. This comes out to be 4. Square root is 2. So from the radicals, we get that 2. And then what's left over? This thing out here. So we get 4. 2 times radical 2 times radical 2 again gives us 4, right? Another way to think about it, the radical something times the same thing. Radical 2 times radical 2 is just 2, right? And then you've got that 2 on the outside. So we're talking about, again, just 2 times 2 is 4. So here we've been finding the hypotenuse. Now we're going to go back. We're going to find the leg. So take a look. We've got 6 for the hypotenuse. But what we want to do is we want to find the leg side. So we're going from the hypotenuse to the leg, the big one to the small one. So we're going to divide, right? So what does that look like? How do we take care of this? Well, remember from Algebra 1, rationalizing your denominator so that you get an answer that's as in simplest form, right? So we're going to multiply the top and the bottom by this radical 2 just to get rid of the radicals, right? Radical 2 times radical 2 is just 2. And that gives us 6 divided by 2. So we end up with 3 radical 2. All right. So, basically thinking about dividing by radical 2 is kind of like dividing by 2, but then putting a radical 2 on it. And in fact, you could think about it exactly that way. Instead of just dividing by radical 2 straight away, you could divide by 2 and then multiply by radical 2. It's just another option. It's just another thought process. It's just another path through the woods. It just depends on how you prefer to think about it. It's up to you. They tell you the length of the hypotenuse of the triangle is 10, and they want to know what's the length of one leg. Okay, all right. So, again, they're telling you that the hypotenuse is 10. Draw a picture, label it. Here's our 90-degree angle. These are both 45 degrees. Draw a picture. It helps. So we've got this is 10, and we're going from the hypotenuse to the leg, so we are dividing by radical 2. Well, what is that? 10. What is 10 divided by radical 2? Once again, rationalize the denominator. And what's 10 divided by 2? It's just 5 radical 2. Okay? Alrighty. So that is a 45, 45, 90 triangle. Our other triangle has a couple more moving parts, but it's still the same idea. This is called a 30, 60, 90 triangle. And so it really does help to sort of keep track of what goes where. The small side, it's sort of the base of what we deal with, is opposite the 30-degree angle. The medium side is opposite the 60-degree angle. And the largest side, the hypotenuse, is opposite the 90-degree angle. Here we have a couple sort of formulas. If we know the small side and we want to find the big side, we just multiply by 2. If we know the small side and we want to find the medium side, we multiply by radical 3. All right? Now, what I'm going to tell you, there's a couple sort of tips and tricks. Rather than like having one formula to pair each different possible side, I think it's always best to always sort of work around this shortest side here. So it's the sort of thing where if I want to use the hypotenuse to find the medium side, I would divide by 2 and then multiply by radical 3. Just because that's less memorizing, okay? I mean, you could just as easily say, all right, well, I'm just gonna multiply by radical 3 over 2. That's an extra thing that you have to remember. All right? So I'm gonna tell you honestly, going just to the small side, right? Because the small side to the big side is times radical 2, right? Times 2 here. And then going from the medium side to the small side is dividing by radical 3. So if you're going from, and this is true all the time, right? All the times that we've been talking about any kind of scale at all, going from something smaller to something bigger, you multiply. Going from something bigger to something smaller, you divide. Simple as that. All right? Let's go ahead. So here I want to find D and I want to find F. So let's do that. So the first thing I want to point out, see how this is drawn? It's not drawn like that. Sometimes that can be confusing. If it helps you to do so, redraw your picture so that it matches what was on the example. Yeah? I mean, you don't have to, but here's some helpfulness for you. So I want to get D and I want to get F. I want to get the small side. It's opposite the 30. I want to get the hypotenuse. It's opposite the 90. So I'm going to go from 5 to D. That means I'm going to divide by radical 3. Which means that D is going to be 5 over radical 3. Which, when I rationalize the denominator, I get 5 radical 3 over 3. And this is all set. Now I want to find F. So I've got the small side. If I want to go from the small side to the hypotenuse, I multiply by 2. Well, 5 radical 3 over 3 times 2, just multiply the numerator by 2. What's 5 times 2? And there you go. Easy. So now it is your turn. Here, what I want you to do is I want you to figure out, they give you this right here. I'll give you a hint. This is supposed to be a equilateral triangle. So this is 60, this is 30, and this is 90 up here. I want you to find S. Okay. So once again, we know that this is, first of all, this is the medium side. So we know that this is 18. We're going to go around this way so we can find all the pieces. 18, from medium to small, we divide by radical 3. So we're going to do 18 divided by radical 3. We'll simplify by rationalizing the denominator. 18 radical 3 over 3. We can actually simplify this further, right? 18 divided by 3 is 6. So we've got 6 radical 3 right here. And from here now, going from the small 1 to the hypotenuse, we multiply by 2. Well, what's 6 times 2? And then that radical 3 is still there as well. And there we go.